Welcome to our CathCAD software training series of videos. This video will provide training on general software modeling execution using the CathCAD software. This training video's agenda covers the following topics. First, we provide summary of the development history of the CathCAD software. Second, we provide background information on the CathCAD software engine. Third, we summarize the CathCAD modeling assumptions. Fourth, we illustrate the CathCAD main user interface and briefly describe the entering of model data into the software. Finally, we execute two design examples using the CathCAD software. We also show the exported software outputs as shown in Microsoft Excel. The CathCAD software was first released in August 2012. The software consists of three software packages: CathCAD Standard, CathCAD Advanced, and Multi-Lumen CathCAD. These software packages all use the same analytical software engine. In each of these packages, the front-end user interface has been optimized for the particular application. The software does not utilize empirical DAA or rules of thumb in computing the software output values. The standard CathCAD license includes all three variants of the software to the user at no additional charge. The software is on its Gen 4 modeling engine that provides the best results when comparing the model outputs to actual items. The CathCAD software modeling engine finds its basis from two major sources. First, the software utilizes the principles found in classical lamination theory. In materials science, a composite laminate is an assembly of layers of fibrous composite materials, which can be joined to provide required engineering properties, including in-plane stiffness, bending stiffness, and strength. A good reference for the viewer to read and review is the textbook Mechanics of Composite Materials by the author Jones. Second, the software utilizes the ovalization theory developed and published by Brazier in 1926. This model was first described in the published paper, The Flexure of Thin Cylindrical Shells and Other Thin Sections. This model is used to compute the kink radius, buckling value, and is also used in the ovalization model. The underlying modeling engine makes the following assumptions. First, the tube is long and thin-walled. Second, the materials used in the design are isotropic, that is, the material behaves the same in all directions when a force is applied. Third, the overall design exhibits linear elastic behavior, which also means the deflections imposed are small. Finally, the design as manufactured is perfect concentricity, and the lamination between layers is perfect with no voids. These assumptions also assume that the connecting layers never delaminate or separate from each other during the deformation process. The CathCAD software assumes the part or design being modeled in the software is after all manufacturing steps are completed, including any lamination or fuse-down processes. The inner diameter, outside diameter, and layer designs should be that of the actual part. The actual part should be representative of the dimensions as entered by the user into the CathCAD software. Some CathCAD users have utilized the dimensions of the lamination outer tube before the lamination process. This methodology is incorrect and will result in incorrect CathCAD model outputs. A good way to check is to ensure the measured outside diameter matches the theoretical CathCAD computed outside diameter. The CathCAD software assumes that the braid layer is completely encapsulated with the matrix matrial. If the actual part made has incomplete braid encapsulation with the matrix material, the CathCAD computed values will not match that of the actual part. The most commonly used CathCAD software package is CathCAD Standard. This package supports non-braid and braid-reinforced designs. It allows for modeling up to 6 layers in the design. It includes the direct exporting of the results to Microsoft Excel. It provides support for the pick count macro, ovalization modeling, and the deflection model. CathCAD Standard only provides support for English or imperial units as of 2024. We also provide a CathCAD software package identified as CathCAD Advanced. This package includes all of the features that are in CathCAD Standard. It also provides support for multi-stranded braid-reinforced designs, hybrid braiding, coil or spiral reinforced designs, and support for English and metric units. We now provide information on the CathCAD main user interface. A screenshot is provided representing the CathCAD Advanced software package. The main screen is divided into two parts. The top of the user interface is the main input screens. The bottom of the user interface is the software's output fields. The command buttons are located on the lower right-hand side of the screen. More recently, some of the latest product features are also available from the main menu interface, such as the deflection model. The basic user interface requires the user to enter the inner diameter, number of layers, and the layered construction of the design as shown. The software automatically computes the resulting outside diameter. It also computes the layered thickness for the reinforcement layers based on the wire size used. When a design is fully entered, the user selects the Compute button to execute the CathCAD simulation function. The software checks all user inputs prior to model execution. If the software finds any issues, the applicable field will be highlighted in red for a period of 3 to 4 seconds. When the software detects an issue, the design model is not executed. This training session now focuses on actually executing a relatively common catheter design problem. This is illustrated by executing an actual design for the viewer. In our example, the form factor is limited to an inner diameter of 0.0300 inches and an outer diameter of 0.0368 inches. The effective wall of the design is 0.0034 inches, which is equivalent of 3.4 mils. The use of the term mils is commonly used in the machining industry. The conversion from mils to inches is 1 mils = 0.001 inches. The software uses these terms interchangeably. The design example outputs from the example uses the latest software engine that was included on the production date of this training video, which was May 27, 2024. It also uses the standard material and braid wire libraries that were in place at the same time. You may obtain different output values if your configuration uses a different software version due to algorithm updates. Your CathCAD administrator may have changed the material database numerical values, which will also lead to differences in the software outputs. For this training video, we execute 2 different designs that fit within the form factor. The first design executed is a 1-layer design. The material used is polyamide, and the wall thickness of the layer is 0.0034 inches, or 3.4 mils. The second design is a 3-layer design. The inner and outer layers are polyamide. The design is a braid-reinforced design. The braid wire size is 0. 7x5 mils, the braid configuration is 16 wires, and the pick count is 60 ppi. The braid matrix, or filler material, is polyamide, since the material that is physically on top of the braid layer is polyamide. The model assumes that the braid layer is completely encapsulated. This page illustrates the first design using the CathCAD standard package. The figure illustrates the input screen as executed by the user. The figure also shows the computed outputs after the model is executed. The design is entered into the software by the user in the following steps. Enter the inner diameter as 0.0300 inches. Enter the number of layers to 1. Set the layer configuration as non-braid. Set the layer wall thickness as 0.0034 inches. Select the layer material as polyamide. The CathCAD computed the outside diameter as 0.0368 inches, which agrees with the expected value of the design. Since the CathCAD model agrees with the product design, we select the Compute button. This page illustrates the same design as the prior page. The single-layer design has been decoupled from 1 layer to 4 layers, where the total wall thickness remains 0.0034 inches, or 3.4 mils. The user will note that the output values from this setup are identical to the results obtained on the prior page. This sort of setup is not normally done. We executed this second example to show the results from the 2 models are the same. The second design is a 3-layer composite tubing design. The inner and outer layers are polyamide. The design is a braid-reinforced design. The braid wire size is 7x5 mils. The braid configuration is 16 wires, and the pick count is 60 ppi. The braid matrix is polyamide, since the material that is physically on top of the braid layer is polyamide. We provide an extensive training video on the subject of braid-reinforced composite tubing that provides much more information on this topic. This page illustrates the exported CathCAD design outputs in Microsoft Excel. This format allows the user to easily compare the results from user-executed modeling runs. This software feature saves the user the time and accuracy in having to manually write down the model results. For our theoretical exercise, for the same dimensions, the polyamide braid reinforced design provides 900% times more torque, as measured by the torsional rigidity value, as compared to the non-braided polyamide tube. This completes our CathCAD training video. For more information, please visit our website at www.cathcad.com